This little thing here is the backbone of a robot. It can grow up to 200 times its size, and it cannot be stopped nor by spikes, glue, nor side spaces. And it could potentially, in a not so far future, save your life. I made mine by recycling some old plastic bag, but researchers at the Hawks Lab at UC Santa Barbara have been studying these mechanisms and creating useful inventions for a while now. The inspiration for this swap robot came from observing vines grow, or in other words, by copying nature's mechanisms, aka biomimicry in its purest form. But what is biomimicry? Biomimicry is the emulation of the model system and elements of nature for the purpose of solving complex human problems. So let's look at some other examples. Other researchers are developing gecko tape, which is an attempt at reproducing the non-sticky grip of geckos to defy gravity. But without traditional glue, how do they stick to things? If you zoom in, you can see these hair-like fractal structures that increase the surface area and act as glue. But if you pull in the right direction, they reset, without using any chemistry. By copying these mechanisms, they have developed gloves with a better grip that allow a human to climb vertical structures. This tape has also biomedical engineering applications in wound healing and replacement of tissue joints. Even if it has lots of cool science applications, the biomimicry process has also been used into fashion. Iris van Herpen is a Dutch designer that incorporates biological shapes and materials into her designs. In architecture, a biomimetic design has also been applied so as to optimize the cooling of buildings by mimicking the ventilation system of antehills. Also into material optimization, usually when engineers are designing a piece for your home, like a shelf for your recently acquired St. Geordie books, they focus first on the functionality of this one, and not in the reduction of material use. They might design something like this IKEA shelf. But recently, thanks to artificial intelligence and new technologies such as topology optimization and computer simulations, you can now replicate the hypothesized weight and properties of the object, and the engine will run and give you the most optimal shape. What I find fascinating about this method is that the end product resembles biological structures, such as this most optimal drone design that after computing millions of simulations and obtaining the absolute best shape that we can create, the end product is really similar from the image on the right, that's the pelvis of a flying squirrel. This is also being used to reduce weight, material and cost, for example in aeronautics, by copying the lightweight skeleton of birds, and in biomedical prostheses that need to optimize functionality and shape, and to achieve better results, copying the shape of texture of natural bones is shown to work best among patients. If you remember in the beginning when I told you that this tiny thing could save your life, as a matter of fact, it can. Mechanisms like this one are under experimental trials to be used to facilitate and optimize intubation processes to patients that have difficulties breathing. With this tiny thing, a procedure that had to be previously done by professionals and lasted minutes, it can now be done by anyone, even by you, in a matter of seconds, saving millions and millions of lives. In conclusion, biomimicry, literally defined as the imitation of nature, has inspired lots of human innovations and cutting-edge design, from the gecko gloves to optimal aircraft design. If you think about it, nature has a clear advantage over us, having had millions of years of trial and error, shapes, colors, and materials. So, if it's so great, why aren't we using this knowledge to solve our problems? Maybe the next life-saving apparatus will not be thought of by humans. It might have already been invented, and we will just have to find it.